Hey everyone, welcome. Today, we're going to do something that I think is incredibly rewarding. We are going to stare right into the face of pure complexity, and together, we're going to learn how to speak its language. You ready? Let's dive in.
Whoa. Okay, just look at that. At first glance, this thing looks like an absolute monster, doesn't it? It's like a secret code from some sci-fi movie. You know, something that's meant to be intimidating. But here's the secret. It's not a monster. It's a story. And our mission today is to figure out how to read it together.
So how do you tackle something like this? Well, the first step to understanding any complex story is to meet the main characters. And that's exactly what we're going to do. We're going to deconstruct this formula, break it down into its core pieces. We'll meet each symbol one by one and figure out exactly what its job is in this whole shebang.
All right, let's start with the star of our show, our protagonist, phi. This symbol right here, this is the answer we're looking for. It's the grand finale of the whole story. Think of it as the state of a system, and that could be anything, really. The weather, a stock price, maybe even a biological cell, at one specific moment in time. Everything else you see on the other side of that equal sign, that's just the how-to guide for getting to this result.
Okay, now let's get into the heart of the action. You see this part right here, the one that's highlighted? This is where all the main stuff happens. This is the main engine of the entire equation.
So at the very core, you've got this function, f. Let's call it the main engine. Now, if our whole formula was a recipe for baking a cake, f would be the main instructions, right? It'd be the part that says mix the flour, sugar, and eggs, and bake at 350 degrees. It takes all those raw ingredients and starts the process of turning them into our final cake.
But hold on. A complex system isn't just about what's happening this very second. It has a history, a past. So let's look at our next key player, which is all about memory.
We'll call this one the memory function, and what's really cool about this part is that it literally looks backward in time. It takes the state of the system from just a moment ago. That's what that little tau minus delta t bit means, a little bit of time ago. And it uses that information to influence what happens right now. It's making sure the system's history is always part of its future. Pretty neat, huh?
Okay, we've got one more major character to meet. So after all the calculations are done, after the present is processed and the past is remembered, everything gets wrapped up in this big outer function. And this is the transformer. Think of it like the final quality control step. You know, if we're still baking that cake, this is the plating. Making sure the icing is smooth, adding the final touches, making sure it looks perfect before you serve it. It just takes the raw output of everything happening inside and packages it into the final, correct format for our answer, psi.
Okay, so we've met the main functions, the engine, the memory, and the transformer. But what actually fuels them? I mean, an engine can't run on nothing, it needs ingredients to work. So let's look inside and see what forces are actually making this system tick.
So if you look inside that main engine, you'll see we have three key ingredients. First up, that big sigma symbol, that just means add them all up. So we're summing up a whole bunch of different external signals or things happening in the environment. Then you've got B and C. You can think of those as other really important conditions or boundaries that are affecting the system right at this moment.
Now, on top of those main ingredients, two other things get added to the mix. We already talked about the memory function, right? The influence of the recent past. But check out this last little term, delta Z. This is so important. It represents a small, random fluctuation, a little bit of noise or an unpredictable nudge. Why? Because the real world is never, ever perfectly predictable. There's always a little bit of chaos.
Okay, deep breath. We've met all the characters, we've seen all the ingredients, now for the aha moment. Let's put all these decoded pieces back together and see the simple, logical story this formula is actually telling us.
And here's how it all comes together step by step. It's actually a process. To figure out the state of our system, you first gather up all the current signals and conditions. Then you run them through the main engine. Step 3, you add in the influence of the system's recent memory. Step 4, you add that little bit of random noise, that unpredictable nudge. And finally, you run that whole result through the transformer to get it into the right format. And there you have it. You get psi, the new state of the system. See, it's not a monster. It's just a process.
Okay, let's just zoom out for a second here. What we just did, we didn't just break down one scary-looking formula. We actually learned something much, much bigger about how to approach and understand any kind of complex information.
So you might be thinking, okay, that's a cool little trick, but why does this actually matter to me? And that is the most important question of all.
Because the answer is this. This formula, it's not just math. It's a language.
It's a super precise and powerful way to tell the story of all the complex, dynamic things happening all around us, from how a disease spreads to how financial markets behave, even to the firing of neurons in our own brain. It's a storytelling tool, but for reality.
And this right here is the ultimate takeaway I want you to leave with. The real power isn't about memorizing what psi or sigma means. Nope. It's about knowing that you can understand it. It's about developing the skill of looking at something that seems impossibly complex, and instead of running away, having the confidence to say, okay, let's meet the characters, and just breaking it down piece by piece. So let me leave you with this. What other complex code in your world could you crack with that mindset?